Thank you for coming, guys. I know this, on the video screen there's folks watching too. Thank you for having me. I'm here to talk about cybersecurity. It's quite a large topic. I'm Fleming Shi from Baracuda Networks. Let's get started. We'll do a quick introduction of Baracuda Networks, a little bit of background of our company and what we have done in the last 15, 16 years. So started from 2004 to 2008. You probably saw some ads in airports. Berg basically comes in as appliance leader. We actually built application layer security appliances. These applications layer, what I mentioned, is OSI layer 7. So SMTP protocol, which is an application protocol, allows you to transmit emails, right? Then HTTP is another one that we actually did a lot of work on. So we actually built quite a few security appliances that time. And in fact, because we didn't want to just get stuck on just email anti-spam products, we built literally 2 or 3 different products very quickly. And that helped us move very quickly because we had a unified platform and a configuration management kind of framework. So we became the volume leader for purpose-built security appliances. And it's study done by IDC. And 2009 to 2010, you guys remember hypervisors, virtualization, everyone loved it. So purpose-built hardware is kind of, wasn't the right way to deliver things. So we actually virtualized our appliances, and we supported VMware, Hyper-V, various different KVM support. Proxmox is one of those open source hypervisor clusters that you can install. And we also added more product families because Barracuda, as I mentioned, we were starting with layer 7, SMTP, HTTP, so we did web filter, we did the email security, then we got a little bit even lower into the OSI layers, and we started to filter network traffic. And also, we started building data security and data protection products, like backup, right? So instead of the good old days, we backed things up into tape. Back then, Barracuda was the first one to put all the data into appliance, then we replicate it into the cloud. And web application delivery and security is a really interesting one because remember, you guys heard of load balancers? Anyone? Load balancers? It was really cool because the idea is to make sure your application runs really high performance. And you can have multiple actual real servers behind the load balancer. And the load balancer job is to direct traffic. So Barracuda innovated on top of the load balancer, actually started building security for that web application. By the way, web application delivery and security is one key area, especially when we evolved it further and evolved it into a way to secure web applications. I'll talk about it in a little bit. So every day we're using web applications, right? From banking, from shopping, right? From going to hospital, booking appointments, all those things. So 2011 to 2013, we actually start seeing more people getting rid of their data centers. They just want to have nothing to do with rack and stack. So they just wanted to consume software as a service, right? So Barracuda actually started building same set of security products, but making sure we can actually deliver the same solution using a service mesh that we provide. So the customer never had to touch any box or any virtual machine or deal with any wires or any compute or anything like that. They just go ahead and assign Barracuda's as the email security service as sort of their next hop before they hit the Exchange server, right? So centralized management for dispersed IT organizations. This is interesting. Okay, perfect. Is it better? Okay. So this is really interesting because as companies getting globalized, they start to have branches and offices in different parts of the world. So therefore, the Barracuda appliances are starting to protect multiple offices across the world. So we had to make sure centralized management is in place, like control center, cloud control, appliance control, gives us the ability to actually deliver the policy and security they need without getting each office to wake up and do the right thing. We actually were able to deploy the policy across the globe. And public cloud deployment started to emerge. Any of you guys remember when did the AWS start their first service or Amazon start their AWS service? Do you remember when? 2006. Actually, it's quite long ago. Yeah. The first service they offered is called SQS. It's a message bus. It's a very simple service. If you're building your program with message bus and having the multiple publisher consumer kind of model, you would have enjoyed that service. And what's really cool is not for a while, people didn't take it seriously because, it's online bookstore, online shopping, shopping store, and they have an infrastructure to now host any application, right? So, but as things moved on, people are starting to utilize it. Security becomes a need, and Barracuda started to deploy our solution in the cloud. By the way, Microsoft Azure was second right there, and we were the first firewall ever deployed in Microsoft Azure. So in 2014 to 2016, I would say we have started to do a lot of architectural enhancements because even in my days when we were building software, most of the times monolithic architecture, right? So microservices is starting to take off in Barracuda because we wanted to provide services to our install base and also new customers. So, for example, advanced persistent threat detection and sandboxing, this is something that you can't really do on a physical box and expect it to scale, right? You have to find a way to find compute that's more elastic so you can identify threats and make sure everybody gets the benefit once the threat is detected. Link protection that protects users at the point of click is very important because these days, websites could be safe today. It could be totally normal. Even government websites could be safe, but if there is a vulnerability and there could be a latent threat to it, somebody can actually upload and inject a content into the website a month later, then use that reputation of the website and spread the malware, right? So it's important. So at the point of click, so whenever you click, we're protecting you. We're scanning that content no matter when, right? That's the idea. And IP reputation, domain reputation are very useful because we can actually drive efficiency at a lower level on OSI layers to be able to detect bad stuff and bad intent. And one other thing we did in architectural enhancement is API first. So we decided to build all our software, every single product, to go through the API discipline. So actually the user interface is just a representation of the API functionality behind it. What's good about that is it allows other tools, other dashboards to integrate with our product, right? So it's very, very useful. And the other piece of it is Office 365 start to take off. So less and less people use Exchange servers, and more people are using Office 365. It's still growing at 30% every year. It's massive, right? So one nice thing about that is now Office 365 is a SaaS solution. And using their APIs, we were able to then look at different threats. And cloud-native APIs for telemetry as well as instrumentation is very important because we can then drive certain security protection very much native to that platform, let it be AWS or Azure. So 2017 to now, what we're doing now is we're continuing our architectural enhancements because one of the key things is you guys probably heard of Kubernetes and Docker. These are containerized workloads. So the ability to actually run your software in a container doesn't necessarily have to be on a virtual machine. It actually can be on a physical box. So any of you guys remember Solaris? I'm sure you guys do. So my first container was zones, remember? So my friends and I will be using a single physical box, but we all have our own playground on that box, and we're not interrupting each other. It's the same idea. And what's being done now is the software is now being packaged into these containers, and you can deploy it anywhere, right? So Google has their container service, Kubernetes service, then Microsoft Azure added the Kubernetes service, same thing as AWS. And leveraging AI and machine learning, this is one area I wanted to point out because just the normal threats that we detect every day, I call it normal, but it's still very, very tough to detect, especially advanced persistent threat. But what if an email doesn't even have a link in it, doesn't have attachment? How do you identify the bad intent, right? So you have to figure out how to do machine learning and drive that artificial intelligence to detect those things. So just a quick thing about some samples of monolithic applications. I used the Barracuda example here. So front end, back end, middle layer, right? So the persistent layer usually is done in a database. Let it be a primary, secondary kind of replication. Usually you replicate all the time. So in this situation,
It's kind of been done many times in the past. Oracle, MySQL, IBM DB2, any type of database happens that way. Then the model view control user interface and control frameworks that drives all the flow of the application sits in the front. So this is the old architecture. So today, a sample microservice will be done. This is actually one example from Barracuda as well. We use something called a distributed database. So it's obviously API enabled. So every layer we talk through API. And message bus based, which allows you to, like I mentioned, like SQS, you can actually have many publishers of messages and workloads and many workers to consume those workloads, so you can have elasticity. And rich cache layer, this is important because we're, the application usually is very well distributed. You have to have locally available caches so actually you can respond on things very quickly. So this is important for threat detection. So Barracuda today, we pass roughly about 2 billion emails every day. So we have to move very quickly. If we identify something that's a threat, we want to make sure all the endpoints in the service mesh is able to capture very quickly, right? So caching is important. So the interesting thing about distributed database, you guys probably heard of Cassandra. It's a very nice database. It allows you to do eventual consistency, which means you don't have to replicate all the time. Because you replicate all the time, you may not use the data all the time. If you have 16 sites, that's very expensive on the traffic. So eventual consistency gives you, let's say you have 100 nodes. You choose to replicate to 3 nodes to make sure it stays, so it never lost. That way, you will never have to replicate to the other 97. And only when a site is required that piece of data, then it will synchronize over. At that point, it's the 4th, right? So you think about that, eventual consistency is really a major efficiency driver. So microservices are built like this. Also, a little bit of background on Barracuda ATP. So as I mentioned, advanced persistent threat is one of the hardest things to detect. These are zero-day threats. WannaCries, Petias, all those guys are the, it's ever since the Eternal Blue leakage, there's many variants of that, basically ransomware and wiperware that's basically really hard to detect. So Barracuda's advanced persistent threat detection layer is multi-layered, so we have static analysis, heuristics, behavioral analysis, as well as sandboxing, right? So just wanted to give you this background, so when I jump into the material later on, you will see why it matters. Okay, so I'm going to talk about the state of cybersecurity, in my view, in 5 areas. Email, web applications, secure connectivity, cloud security, which is very interesting, very different from normal. If you think of the cloud security as really just firewalls, no, it's really different. And also data goes horizontal. There's 3 different states of data we got to make sure we protect. So many stats, right? You guys see it on the newspaper every day. Just the other day, I heard about someone using a laser pointer, playing with all the smart speakers, was able to actually open garages, right? But anyway, so everyday organizations, like for example, 30% of the organizations were infected by ransomware. A lot of folks I think the first wave of ransomware attack was attacking consumers. They were asking for pennies, right? Like $50, $100, or maybe just a crypto coin back in the days. But it's gotten much worse. So starting with email, I think you guys know Maslow's hierarchy of needs, right? So physiology, you gotta have some place to live, have water, have drink, just being able to stay alive. Safety is the next one. Feel secure, right? Financially and physically. And eventually love, you got a community feeling, family, friends, and esteem, and eventually get to achieve greater things. The reason I bring this up is attacks to Barracuda, through our eyes, are very similar. So I joined Barracuda in 2004, right? It's literally 15 years ago. That time, remember spam? Spam was really a pain in the butt. Everyone hated spam, right? So just causing trouble, right? And also we saw that random attacks. Just like Maslow's hierarchy, it's basically when you get better in one thing, you move on to the next level. You feel like you have done the right thing. So for the bad guys, they've done a lot of that random attack first. Then eventually do smash and grab. Basically find CVEs, all the vulnerabilities. Right? If there's a vulnerable web server, what do? I figure out how to get in there and identify all the all the sites who are not patched, right? In that situation, they can actually, cause trouble. Eventually, very targeted attacks. This is spearfishing. I think Andy mentioned that he remembers spearfishing as a word. This is important because spearfishing is really targeted attacks, social engineered, looking for ways to actually gain your trust, right? And eventually, the worst out of all is basically nation state, right? Manipulation of, using social media and those kind of stuff. So I'm going to touch on this chart real quick. I did want to make sure the acronyms are explained so it doesn't look difficult to read. So you can see this is logarithmic chart right here, right? It shows email being the first, probably the greatest attack surface, right? So the number of attacks you can see, BESS is our email security service, email security gateway. If you can look at this data, it's much longer. And if you look at logarithmically, it's over hundreds of thousands of threats we're seeing. And if you compare to other attack surfaces, they're not nothing, but they do happen, but a lot less than email. So the reason I wanted to talk about that is this particular threat that we detected in 2017. You guys remember Petia? Right? So Petia, the first appearance was March 2016. It's just a class of ransomware. It came out from Eternal Blue leak. So not Petia is basically happened like almost a year plus later. And the idea here is I want to talk about 3 different attack surfaces that happen with this particular threat. So what does it do? The method of delivery, for example, MEDoc is a financial application used by a lot of Ukraine organizations. And also they deliver this threat through email vector as well. And the trouble is it's not a good ransomware. There's no ransomware that's good, by the way. The ransomware in this situation actually failed. It did not, if you paid the Bitcoin, it will never give you the file back. It was actually broken. It erases your hard drive. So unrecoverable encryption and damages the system. Master boot block as well as master file table. So this is a CERT screen that happened during the day of attack. As you can see, there is an attachment here, right? This is the order request, sort of, for quote. And this particular file is it's actually exploiting a remote script execution kind of vulnerability in Windows. It then, if you open it, it will download a spreadsheet. That spreadsheet has a obfuscated JavaScript in it. That will then download an executable, eventually run a PowerShell, then eventually encrypts your system and basically breaks your file system. So I just want to make sure you guys know this is from Ukraine, and this is their site. And that day, through our system, you can see we actually, I'm going to jump to the next page because it's much easier to read. So obviously our time is a little different because Pacific time. So we had over 3,287 blocks, and we saw this many hits, and came from 413 locations in the install base, right? So it's the same request for order. You can see that. So the point there is that how do we actually trigger? How do we trigger this? Is because we have a set of units in the field. We will be immediately notified if the malware is spreading, right? When we see that behavior, we're able to then extract the document and make sure we do a sandbox analysis on it and make sure all the indicators related to this particular threat is covered, right? So I just want to point that out. It's very, every day we see this kind of stuff. It happens so fast. We have to really basically react very quickly. So remember the architecture that we put in place needs to react in milliseconds. In this case, it was like 40-some seconds or something, 42 seconds, right? We collected a whole bunch of actual malware. That's basically not Petia. So this is the attack 2, which I call the attack 2, which is the email attack surface, which is pretty effective. If you ended up opening that file, you will be attacked by NotPetya, right? And the next one I want to talk about is this: how does the technology work? So basically, this is an example of an ESG. So in our email security service, the SaaS solution, you replace everything in the blue box with our SaaS solution, right? In the ESG scenario, customer do have a physical box or a virtual machine. So what we do is basically email goes all the way from here to the email server. We are actually a message transfer agent, MTA. Well, our job is like a bump in the wire. So before Exchange server gets it, we get the first view of it. So in that gateway scenario, we obviously have various different layers in protection, but it's important to realize having a gateway in front of your Exchange server, your Office 365 MX record allows us to basically examine the malware. We take the email apart, the envelopes, the content, and also the attachments. We make sure we scan them. So that's the technology. And one thing I do want to touch on is these are the different files that we see getting weaponized. And the biggest one is PDF, actually gets a lot of suspicious counts. But you can see the Office documents gets the most actual malicious because they are much easier to weaponize, right? You can put in a macro inside your spreadsheet. You can put PowerShell and all those things in there. Of course, email. I would say portable executables. Of course, when you see them, they're binaries, right? So less on email, but we see a lot of them in networking, network firewalls. So beyond APT, remember APT is Advanced Persistent Threats, and phishing, here comes spearfishing. Spearfishing is very different, so I just wanted to make sure we point it out. Contains links to malicious sites for phishing, but not for spearfishing. It's just a piece of text, right? It tries to gain your trust and fool you. And sent to many people. Usually it's really send it to a very targeted person. And most of the time they want you to transfer money or steal your social security numbers or figure out some way to get you to give them the credentials. So spearfishing is a big issue. And the problem, that's why it's a big issue, is it's really hard to stop. Because imagine the earlier section I mentioned, the email security gateway, we're able to detect links and scan the files. In this case, we can't, right? So all this, it bypasses everything, right? So what do you do? In this case, the only way going about it is actually figure out how to understand the communication pattern between your people, right? In your organization, your friends, and if you're using the right signature, sometimes, like I use our CEO as example, people found out his name's William Jenkins. So the bad guys thought, maybe I just signed the signature William Jenkins. Guess what? BJ never uses William Jenkins. He always uses BJ, right? Or Bill. B is, so that. But now, yeah. You told the web. That's okay. There are other indicators. I'll give you another example. When you look at who is accessing the email, who is sending the email? The sender information is very important. Does BJ send email from places other than Silicon Valley, or it's very rare, right? Can he be in two places within 5 minutes of each other? So those are all the data that we can use to actually identify the behavior of the sender or the message, the intent, right? And also sometimes you look at, because every organization, every company has almost half our executives all on the website, right? People knows who is the CFO, who is the controller, who is right, who is the legal department. So a lot of times they utilize the social engineered information to actually build the actual weapon. So it's very important to actually use AI here. So the way we do that is we obviously a very good partner with Microsoft. So we actively work with their APIs to, instead of using MTA in between, we're able to look at historical data and actually understand the communication patterns and understand the right things, right? And who sends email from where, all that. And that way we can build this is not unsupervised machine learning, this is supervised training. So we classify, we utilize the right information to make sure we train a corpus of email, train a model with a corpus of email, eventually use the model in real life. So that's what we have done with Barracuda's products called Sentinel. So now I jump to web application. Bengaluru, yes, he's smiling there. It's in India. Our team is in India. So a lot of times people think, websites are all protected with a firewall. Firewall doesn't do it. Firewall is layer 3, 4. It can detect IP addresses, domain reputation, DDoS, maybe those, right? But application layer requires a lot more in-depth. What kind of parameters the application is taking in from the internet? What kind of user agents are coming to your website, right? So in fact, this is a scary number. 10% of all the web applications are protected, only 10% are protected by a WAAF. So that means every day we're using banks and travel agents and everything we do online. How are they protecting us, right? We don't know. So that said, that's really a big problem. Even companies like Equifax, you guys remember that breach, they had WAAFs and they probably had a sophisticated WAAF, but the problem is a lot of times is because it's so complicated, if you don't configure it correctly, what does it do? It breaks the application. So people set it into audit mode. Audit mode doesn't do anything to protect you. It just tells you something went wrong after the fact. Okay, so it's important to figure out how to build a product that is actually helpful, easy to use, and be able to protect people, right? So it's the #1 attack vector leading to data breaches by Verizon. So back to this Petia breach, the attack. So this is attack 0. So the reason it's attack 0 is someone had a sleeper cell in the MEDOC servers, injected content into the updates. So which means when the software does, a lot of times we set our software to auto-update, right? Because you don't want to be bothered when you use it. Say, hey, do you want to update now? You want it to just auto-update. So the problem with that is because they figured it out, so they basically changed the content of the update, right? And basically applied it with enough malicious intent to basically did the same thing it does with that email. It downloads and attacks your MBR and MFT, right? So it's very important to recognize this is attack 0. So somebody went into the servers, the guys at MEDOC didn't even know that happened. Then they just kept cool and didn't want to do anything until later on. Okay, so like a sleeper cell. So things we do. This is interesting. So this is what I wanted to show you. So WAF actually has what we call the OWASP top 10 and basically provides various different kind of protection. There's many others, cross-site scripting, injection, content injection. A lot of web servers actually has issue with vulnerabilities that allows privilege escalation and eventually content can be changed. So how does that technology work, right? So this technology works as a reverse proxy. So reverse proxy is basically sits in front of your web server. Its job is to intercept the HTTP request and HTTPS request, and its job is to actually analyze the request before it goes into the real server, right? So, and what we have done, again, this is a very highly intense workload. So we have a solution actually runs in Microsoft Azure, so utilizing that elasticity. So because web applications are constantly going to get bigger, more users are going to use the apps. And not just users, by the way. A lot of times it's APIs from your app on your phone. It talks behind the scene to the server in the cloud, right? So we have to make sure this kind of workload is protected. So that said, secure connectivity. So in many ways, my very first firewall is played around with was Cisco PIX. I don't know if you guys remember that. But in between, I built my own Linux firewall and played around, and then eventually, but secure connectivity is no longer about firewalling. Firewall is designed to block or do certain type of ACLs in front of a set of computers, right? Or a network. But secure connectivity is about you can connect anywhere between your cloud environment, let it be AWS, different regions, US East, US West, to your office, to your data centers. Yeah, by the way, this is in Austria, Innsbruck. Yeah. So the secure connectivity story comes into play here for the NotPetya story as well, because this is going to be on a quiz later. This is attack 1, right? So what it is what happens when the update comes through. It has to go through a bunch of systems and networks. If we had the right solution in place, it would have actually stopped that particular update, right? So I just want to make sure you guys pay attention. So that said, all the attacks related to NotPetya, these 3 things, I just want to make sure. And never forget attack 0. That's probably the most dangerous one, because all they have to do is figure out a way, some kind of vulnerability to your server, then they start changing the content of your updates. And the update will still work for your software. They just added new things to it. Yeah. Okay, so in a scenario of a secure connectivity or firewall product, next-gen firewall, what we do is I use this web security gateway example because this workload actually lives in the firewall as well. And we also have a separate product for that. But what it does is it's a transparent proxy. So you can actually work off a network just like normal network. You have a router firewall at the top. Then basically in the logical breakout, you have a transparent proxy. This is not a reverse proxy. This is a proxy that basically reads all the incoming traffic. So the request that goes out, it captures it and inside the network. Like if your computer is doing an update, it will actually be captured by this proxy service, and it will do the scan for you transparently. So this is a layer 2 bridge. Literally, you have basically one LAN port basically connect to each other. Then it builds a TCP session on top of that bridge. And in this case, it's more of a single arm scenario. Most of the networks are like this because they don't want to have any bottlenecks in between. So you can have WCCP or Cisco protocol to drive the web traffic to the proxy. So that's how that works. So that said, yeah, that's basically what I was explaining. So we also, most of all the products that we have also handle SSL. So we can make sure your user agents, your systems trusts the device we put in place as an authorized, basically signer, certificate signer. So then we can actually look at inside the SSL traffic. Okay, so IoT beyond your household smart devices, I mentioned. Actually, IoT to me, I have Alexa and those devices at home too, but I'm very cautious. I usually turn them off. But if you look at it, millions of entry points. The IoT, like Alexa, I don't know if you guys remember several months ago, someone's device actually start making funny comments like the Koreans are attacking. Did you guys remember that? It actually, what happened was someone hacked into that device and able to actually change the commentary, right? So the problem with that is everything in IoT for households are eventually connected to a set of servers. What happens, basically you suddenly have millions of doors and that door can lead to someone else's house, right? Think about that. So as I mentioned, networking from home to ISP's environment, eventually to central service, then eventually to other homes. So that's the danger. Industrial IoT is quite different. And industrial IoT actually is robotics, right? So we actually support a lot of customers who make cars. And one of the important thing about that is most of those robotics are not new. They have been around for many years. They're running Windows 8, some older Windows, right? And the software that's designed for that robotics to function, normally they don't want to change it for, if it's not broken, it just does the right thing. The tricky part is it's vulnerable to a whole bunch of Microsoft vulnerabilities. right? So like the SMB, Eternal Blue vulnerability is obviously there for these devices. So what happens is when someone captures the environment, they can actually get into industrial IoT and mess up the production line, right? So again, automated updates, tricky. Most people don't want to update them, the software, and it's because they don't want to break their production line. So that said, this is important to pay attention to industrial IoTs, because from airplane makers to car makers to anybody who are using robots, they're likely running a really older version of Windows. Like for us, we would never want to use Windows 8 or older Windows, right? It's usually something that's doing things. Yeah. So we have some use cases I wanted to share with you. Basically, edge devices, predictable maintenance, all the right things we do to make sure we build a shield around that industrial IoT, right? That basically robot. Think of it, even it's running a more vulnerable operating system, if you build the right shield around it, what we call the secure connector, sometimes we use magnets to stick next to the robot, and so it actually protects the robot's communication, cyber communication. The magnets is designed to mount our device right on the robot. Yeah, so we have that option. Just so if you have project at home you want to play with, you can use that. So in this case, it's it's air conditioning as a service. Obviously we're inside here. You can probably see a little logo right there, right? So our job is to embed into these devices in the field, right? And Barracuda, I just want to touch on one thing. Barracuda started building the network firewall 15 years ago. Before it was a different company. It was an Austrian company. We built that product for ATM machines. So which means back in the days, you have to have that connectivity, have to have stability and resilience, because ATM machines cannot go uncommunicated, or something cannot go wrong with it, right? So the information has to flow correctly. So we built a protocol that's our own to allow us to actually have multiple medias to connect to that device. So you could even supplement it with the 3G back in the days or 4G modem, so you would never lose connectivity. So that's the air conditioning use case. The power grid monitoring is another, I would call it basically managing devices. Like if you think of all the generators people are using these days, and you want to make sure they're secure. A lot of them are smarter than before, so it has a communication channel. You don't want anyone to tamper with that. Smart city projects allow us to also roll out cities where you have better connectivity all of the municipalities. So the next one I want to talk about is cloud. So this is overly used word. People call it cloud. I call it a bunch of servers. Personally, I used to build data centers, so servers were just going, and really cloud is other people's servers, right? The challenge here is that infrastructure as a service is inherently very complex, because what they're trying to do, they are trying to automate deployment of your workload. So they're building a lot of configuration and management plane features to allow you to elastically deploy and manage and configure. And visibility of assets is a problem, because now your server is no longer in your data center or your own control. It's all over AWS or all over Azure in multiple regions. And if you have a really successful service, you're likely going to have thousands, if not tens of thousands of systems, right? How do you gain visibility to that? And who is using what, who has access to what, is very important. IAM, that's basically access management, identity access management. Configuration drift is very important, because when people, I just throw out a question real quick. How many people know how many services are in AWS today, the native services AWS offers, roughly? 45, 60? It's about 160. Yeah, and Microsoft Azure is doing about 170, right? The problem is every year you go to their their event, let it be AWS reInvent or Ignite, they always have new services. The problem with these services, there's nothing wrong with them. They're all very nice services if you know how to configure it correctly and securely. If you don't, then what's going to happen is you're going to leave some open door. For example, some quite sizable company actually left their Elasticsearch port. Elasticsearch is an indexer. It's a full document search database. They left the port open to the world. Guess what happens? People can go in there and just select star, right? Dump a whole bunch of data out. So that said, those are the things you have to watch out. And can you really trust your infrastructure? After you run tens of thousands of assets in the cloud, how do you know if not an insider or somebody else already went in and implanted something, right? So in the industry, there's another overused phrase right now. It's called zero trust, right? It really means you rehydrate. You don't trust it. You basically run the service with your systems for, let's say, 3 months, then you destroy everything and restart, redeploy. Because it's in the cloud, because everything is infrastructure as code, you can do that. You can actually manage to do that. In the old days, it's impossible. You have to unrack all the servers and redo the OS. It doesn't work that way anymore. With the cloud, you have the ability to have that zero trust kind of methodology and basically be able to rehydrate your entire workloads. So also, there are two different personas that I describe here. So the guy on the left is a software engineer. We have a lot of them at Barracuda. And we have like maybe a much smaller number of security professionals because every company is a software company. It's almost like that now, right? So everyone's building software. Doesn't matter if you're a bank, you're Walmart, you're building software. So these guys are trying to build fast. And when they build fast, they use public cloud because that's the best way to get things going. In fact, within Barracuda, I have a joke that says, friends don't let friends build data centers because it's really hard to build. It's really hard to compete with guys like Microsoft and Amazon, right? So you go build software, you build it fast. But security and compliance has to remain on the top agenda because, with all the privacy laws that's already around, GDPR is one of them, you're going to have to make sure you're in the right posture. You have to have continuous compliance monitoring to make sure you can sell your software to other people, right? So the problem with these two is there's inherent kind of friction between them. One wants to go fast, one wants to slow you down. Okay, so that's why I wanted to make sure you guys remember these two personas is really what's driving the digital transformation to public cloud. And right now, I will say sometimes they win, but really they both have to think about security, right? So security in cloud is not about building a firewall. Security in cloud is about making sure you're using the cloud correctly. You're utilizing the native services correctly. If there's misconfiguration, had this happened in the past, one of the engineers probably needed to have access at home because they wanted to build fast and build all the time, right? So what happened is you open a security group port. In the old days, it's just a port number, port 22, and you basically, let the port open. And guess what? Amazon will throw a fit because immediately it will detect that's abuse. And a lot of times, if you're not using strong password, it can become a part of a botnet, right? So it's important to pay attention to these two personas, and everything we build has to revolve around them. And so they allow them to build fast, but constantly check and balance, make sure they don't have any configuration problems. And that's cloud security, actually. So this is what sort of one example of it. So we do have a product called Cloud Security Guardium, but what it is it ingests telemetry from the cloud environment, because just like normally every system emits some type of security logs, right? Think of syslog in old days. But telemetry comes from like CloudTrail, activity log from Azure. They all can be ingested, and that will give you indication of what happened in your environment. And from there, then we can actually talk to the cloud provider using their native APIs and describe what's in the environment programmatically, not manually, right? Programmatically. Then we get all that information, then we can actually provide a visibility to your environment and eventually identify, this is the normal behavior of using, your servers running this way at this level of CPU load is correct. If it goes beyond that, maybe something else is happening to the system. So generally, this is what we're doing as we are prepared for public cloud level security. So it's very different from the traditional on-prem firewalls. So data in 3 different states, right? In motion, at rest, and in use. So in motion, obviously the data is transmitting through, as you can see, Berg could have provided solutions like that. So firewall will be a good product to protect data in motion, or web application firewall, or email security gateway, because it's a data plane. We're a MTA there. At rest is basically once it's landing S3 buckets or in your storage devices, you want to make sure the data is secure, right? Or malware can come in the same way as good files. How do you make sure you get rid of them quickly? In use is tricky because if you're actually running, in use sometimes is you're manually touching it, like using a tool to change the data, but a lot of times it's really just part of the program. It's in memory, right? It's getting handled between functions and routines. So in that situation, reverse proxies, it actually has the ability to look at your memory segments and understand what objects are going in and out. It's important. So what happened to Equifax, I wanted to bring this out, is just to show how bad the situation is, right? So when the Struts vulnerability was discovered, I think it's the CVE 2017-56338. When this was discovered, it was kind of out there, but so bad guys actually gained access shortly after, like less than 2 months, roughly about 2 months. Then once they gained access, they didn't do anything. Nobody knew anything. For literally about 3 months, no one at Equifax paid attention and understood they were breached until sort of end of July. Then they kept their silence, right? They tried to clean up quickly and try to figure out what the damage is. And at the end, it's 143 million records. That includes our driver's license, it includes our previous addresses we lived in, our siblings' names, birthdays, right, social security number. The worst of all, just in July this year, I think they were asked to pay $700 million, right, as damages. Yeah. So that said, Equifax, this is a really good example of how insecure the environment is. You would imagine a credit, sort of score company that keeps your credit should be very secure. They may have the WAAF, but I'm telling you, they probably didn't turn it on into active mode. They were just afraid to break it. So this is a study we did this year. So far this year, 50 municipalities already got attacked by ransomware, right? So there's a few have paid the ransom. Some other guys didn't want to pay the ransom, but then paid a higher price in recovering the data. So the reason here is that I think the bad guys are targeting the cities because there are a lot of sensitive data in the cities' government agencies, and actually very important data, right? So obviously we have a solution just to think about how to really make sure you're backed up all the time. When ransomware attacks, you don't want to pay the ransom because when you pay, you're supplying them with more money. They will mount new campaigns. And what's worse is cybersecurity insurance is out there now, so they're demanding higher pay because the insurance companies probably got deeper wallets, right? So it's cyclical, pretty bad problem. Okay, so I mentioned a whole bunch of technology. I want to bring out the story. I noticed there might be a couple folks from Asia. If you have, do you guys know who this person is? Any guess? He's Zhuge Liang, right? Any of you guys speak Mandarin or no? Okay, so he's the Imperial Chancellor. So the reason I want to bring this story up is I wanted to find out, have you guys think about what else we can do with data. So he's the Imperial Chancellor in Han Dynasty many years ago. And his job was to defend his king, for sure. But the problem is he was giving a task to actually gather 100,000 arrows because he was at the beach, and the attacker Cao Cao, you guys probably know, very powerful imperial leader, was about to take them down. Right? So his job is to get 100,000 arrows. You don't have 100,000 arrows. You're in an island. Right? So actually, this story called Red Cliff, the Battle of the Red Cliff, it's actually available on DVD. You can find the movie and watch it. It's spectacular. It's beautiful. But the story here is that he eventually figured out how to do this because one of the 3 days that he was given 3 days, one of the 3 days was foggy. So he rowed out. He actually got all the boats together, stringed them up with a straw, covering on top. So it basically, covered the boat. And he went out to Cao Cao and just kind of intimidated him. Say, hey, we're coming after you, making noise, right? So what does Cao Cao do? He shoots arrows at him. So he collected more than 100,000 arrows, went back home. Now he has the weapon from the adversary to protect himself. So the next day, their attack actually failed because of this. The reason I wanted to bring this story out is what can you do with data, right? So bad guys are constantly creating malware. And any of you guys have gone through security awareness training? Have you guys? You have seen that, right? And the problem, which program did you use?
No, I've had to deal with spies.
Spies, okay. Yeah. So the issue with security awareness training is that it's always simulated. People have to create the content to actually to cause you to do the wrong thing, then teach you, then they figure out how to actually train you. The problem with that is simulated content is not that good. So what's happening here in this story is that what if we turn the bad guy's content and disarm it and turn it into training material immediately, right? So then you end up getting the bad guys working really hard. Everything they do, every weapon they produce, we can actually disarm it and make it available as training. So that's the thought piece that I wanted to land today. Is in the future, we're going to have to figure out ways to not only deception type of defense, but also figure out ways to make the bad guys actually suffer in many ways. Actually, they actually end up building things, then you disarm it. The reason, I'll give you one example. It's hard to actually explain that. But if you look at Office documents, they're actually compressed zip files. You guys probably know, right? The docx, right? So if you open it up, there are a bunch of things in there. Basically, it can be weaponized. Let's say the bad guy's putting a macro in there. The macro's job is to launch a PowerShell. In that situation, we can disarm that particular macro and still coach the user, right? And that particular coaching process can be done completely, programmatically. Yeah. So it's more of a real-time training using bad guys, malware, disarmed. Think of that, right? So anyway, I wanted to share that with you, and that's my presentation. Any questions? Thank you. Anyone had any stories to share on cybersecurity? Yeah, thank you. Awesome. Yeah.
Your logarithmic graph.
Yeah.
Take the mic up to him. Were the individual colored segments linearly stacked, or expanded?
Right. So in the graph there, everything's logarithmic. So basically, once it's stacked together, they're basically representing relative to that particular line, right? So my point there is, I will bring this back. Hang on one second. So the reason I did it using logarithmic, so you can see other stuff. Otherwise, you won't see the anything from it's coming up. This one, right? Yeah. So basically, this red section represents 100 right here. Then this section is almost the same size as the rest section, is also about 100. Yeah. So they're not, in a sense, where, you know, they're not relative. They're basically static. Yeah. But you can see here the biggest problem is email. I wanted to share that with you. Why email is the first attack surface, because it's so easy to jump into. Yeah. Any other questions? Any cybersecurity events you guys have experienced? Anything in the material that you want to ask? So far, so good? Oh, there's one question.
I was just wondering, what is the current technology in terms of like encryption and decryption, and how to implement this in a distributed fashion, especially in the context of a GPU computing?
Okay, so you're talking about encryption as in SSL, sort of?
Or some like protocols other than traditional like RSA or something like that.
Right. So I think the question is related to encryption, how the content is getting encrypted, right? So in those scenarios, are you talking about storage or more on the flow? Like for example, encryption in the web flow.
You mentioned some application on the IoT stuff.
Mm-hmm.
Just curious, since those distributed devices are more put more focus on the power efficiency and try to
Yeah.
use less battery.
Right.
And I'm curious, like in terms of communicating, whether there are some new protocols or some new design of chips that vary inside of the IoT devices, for security communication.
Yeah. Actually.
Or trend, or
Yeah.
according to your experience or observations.
Yeah. My observation right now is completely lack of encryption in the sense where a lot of the IoTs, they're actually, because they're so inexpensive, they're looking for ways, like for example, ARM is one of the most used chips, compute processors, and while it's able to do encryption, but it's not hardware assisted, right? It's not ASIC based.
I would like to add to that, around 7-8 years ago, we were looking at mobile traffic, analyzing mobile traffic from telcos, and we saw most of the app traffic was not encrypted at that time. It was a similar situation. The hardware was...
You said battery is a big problem. Because they run on a battery, and in this situation, you know, anytime you utilize anything that's like a GPU, it will drain the battery very quickly. So I think that the key there is the communication protocol. So one of the things we practice also is you don't encrypt the entire transport. You encrypt just the payload. You can build a way to actually, people can see the content, but they don't know what to do with the content. The content itself is meaningless until it makes it to the other side, right? So, but in that case, you're doing less work, but not no work. So in that way, I would say any IoT that's inexpensive and probably is not doing the right thing for encryption. And the certificate management is another nightmare because certificate can get lost, and the cert authority can actually be taken over, right? So in that situation, like what we do is we have a trust with our device and the users. So the browser actually trusts Barracuda CA. Then you can do things more locally in the environment. So you don't have to. So our box or our physical device or virtual device can actually do the encryption locally in the network, right?
That means we have to trust you.
That's right. So yeah, we can, in that situation, you basically have to roll out using a group policy to make sure our CA is trusted in that environment. But it only affects that environment because that cert is different for every customer, right? That CA. Yeah. So you have. I think I think so. We have to find ways to really kind of change the game a little bit because, look, they have our social security number. We might as well go out there and just show people, the thing is they can create fake identities, right? And I think because of that, the exposure, I would say post-breach of Equifax in that magnitude, we have to realize what we're dealing with. We have to back up our data. We have to make sure we use MFA. So even MFA is now 100% safe, right? People already figure out how to change the SIM, right? They do basically figure out a way to, if you see on your phone, say, hey, someone's, changing your SIM is no longer valid. Someone's actually hacking your SIM, right? So that's a very problematic issue too. So I think we have long ways to go, but you have to really understand. Like, for example, the reason I mentioned cloud security is different is because app builders today, they're very different from the old days. Not that old days, but you used to build software, you used to compile it, then you system test it, right? Then you put security around it. Today, people are building it so fast. HTTP is actually the new transport. In the old days, you write server client software using UDP TCP protocol. Now you're building it with HTTP. WebSockets, right? So I think it's really important for us to pay attention how quickly every company, every organization has software engineers. How do you make sure they're secure in the sense of creating the software? Yeah. Yeah.
Of course, your software engineers are another threat vector.
Yeah.
Download things from NPM, and who knows what, some dog-eared repository.
Right. I think that's why even when you're not intentional, because a lot of times convenience matters so much, you're leaving some software engineers actually checking their keys into GitHub by accident, right? Then guess what happens when you're checking your keys and tokens? People can get access to your databases and other storage, right? So I think as we are becoming more open to the cyber world, building software, building applications, getting things more efficient, we have to really think about how to secure it at the root. That's why looking at the code, looking at the infrastructure code. There's a YAML, for example, is an infrastructure code that basically goes into every orchestration framework, let it be Kubernetes or Docker Compose or anything like that. So you have to examine the descriptor of the YAML to make sure you're not opening the ports you don't want to be opened, right? You guys probably know IP tables in the old days. You feel like there's one layer of defense on IP tables, but today all the workloads are containerized. There's no physical. There's no place you go typing. Okay, what kind of ports are open, inbound, outbound. Pre-filtering, post-filtering, right? It's all within the container. So it's kind of, to me, I think it's okay. Just we have to.
I think it's, from my perspective, it's sort of like the bad guys are kind of winning, but they've also, there's not a ton. I would say there's probably about an equal amount of bad guys and good guys, and we need a lot more good guys before the bad guys start really blowing up and really starting to take advantage of all the money that can be made in the industry of being a cyber criminal. And so we really need to emphasize somehow education and people getting into the security industry in the space. Because if you even just think of the things that are happening right now that we're not really aware of as public people, but power, energy, grids, all of the equipment that is used to maintain that, or all of those are connected now, and everything that's a temperature thermometer has a sensor on it.
Yeah.
You can hack into that and potentially break into a nuclear power plant that way, or a big HVAC company, or a big Caterpillar, right? That's got tons of machinery working on tons of different big so the threat surface is huge, and I don't think it's been tapped by all the data, our data's out there.
Yep.
You know, we also have ways to sort of work with our banks and, you know, have sort of, you know, a little bit more safety nets now than 5-10 years ago, where it was just detrimental if you lost, you know, your social security number. Getting that stuff back is terrible. So I still see this, but the potential is so great if we don't start realizing and taking it as a serious threat, and that we really need to have people in the industry and being good.
Yeah.
Then it's just, it could be really, really bad. It can get really bad.
The other way to look at it, if people are paying insurance for cybersecurity, I think it's an indicator that bad guys are winning some ways, right?
Well, bad guys have initiative and inertia
Yeah.
and incentive,
Mm.
and you don't know necessarily what they're really doing.
Mm-hmm.
And in the past, it was just literally doorknob handling.
Yeah.
And now we have actually far more sophisticated things. So like, my question for you as an example is Baracuda Networks,
Mm.
a member of the Association of Old Crows.
I don't think we're a member, but we should.
The Association of Old Crows is a
Hmm.
30,000 member organization of electronic warfare people.
Oh, wow.
Yeah.
Would they accept our membership?
Oh, yeah.
Okay,
I'm sure
that would be
they-
cool.
I'm sure they would let that.
Yeah.
I mean, I have 2 of your guys' T-shirts.
Oh.
I'm not an old crow. I mean,
Mm.
they're serious people.
Yeah.
They're out there to kill the
Yeah.
enemy.
Yeah.
Exactly.
That, I got you.
Yeah.
That's really interesting. Yeah, definitely. For me right now, also I don't feel like it's an even playing field, because the bad guys, ever since cryptocurrency came about, they can actually benefit from that very, very efficiently. You know, while we are still organizing, figuring out how to defend them with, you know, day-to-day kind of efforts, I think at some point defensive measures and things we put in place should also be in the cryptocurrency kind of economy. Yeah. So there's a couple of companies out there looking to do that.
A lot of companies out there.
Yeah. Well, in a sense, we're trying to monetize defense, but using cryptocurrency as the transactional platform. Yeah. So things can be more automated. Cool. Great questions. Yeah.
Well done.
All right.
What can be done on a small budget basis without getting a PhD in computer security?
Oh, I think just really kind of know where your data is to start with, because I think that is probably the lowest barrier that you can start with. Basically, make sure your data is secured, right? So what that means is, if you have it on a server in a data center with a web in front end, for example, that's potentially a risk. You have a database, for example. If you have an application server running in front of it, you want to make sure to at least be prepared to react to a potential data loss. On the personal and like email attack perspective, just really pay attention to I will say the message itself. If it's got links, you really have to make sure the link is pointing to the right place. Do you know what typo squatting is? I use example. Typo squatting is basically people create domains using typos. Just look at the letter M, right? The M, if you put R and N next to each other, it looks like M, right? Right. So it's to the naked eye, if you're not careful, you will click on that link and you think you're going to Macy's.com and to pay your bills. But they could easily fake that and and make sure they capture your username and password on the way there. So really pay attention to that. And I think documents, anything with active content in the document, you have to be very careful, like macros or JavaScripts, anything like that. Yeah. I think those are all don't cost too much. If you're using Office 365, they already have some level of security in that way to protect you. Yeah. Great. Thank you for having me, guys. Thank you.